Hello everyone, my name is Mohammad Bilal and I have completed my dissertation for Msc Advanced Engineering Management under the supervision of Dr. Safer Gufari. Today I will be presenting my poster for Msc dissertation on the topic of comparison between fracture performance of modified hard rolled asphalt, the HRA, and hard mix asphalt, the HMA mixture. I will start with the overview. My dissertation focuses on understanding and comparing the fracture performance of two major pavement materials, hard rolled asphalt, the HRA, and hard mix asphalt, the HMA. These materials are widely used in road construction, but they behave differently under traffic loads, temperature changes, and environmental stress. The goal was to identify which material performed better in specific conditions and provide guidance for building stronger, more sustainable pavement. Moving on to the aims and objectives. Aims to critically compare the fracture performance of hard rolled asphalt and hard mix asphalt mixtures to identify the key material and environmental factors influencing fracture resistance and durability. Objectives: compare mechanical properties and fracture resistance of HRA and HMA mixtures. Investigate the impact of binder content, aggregate gradation, and environmental conditions, e.g., temperature, moisture. Provide recommendations for material selection based on performance under varying conditions. Moving on to the rationale. The need for sustainable high-performance pavement materials is increasing due to heavy traffic, changing climate, and the demand of cost-effective infrastructure. Currently, HRA and HMA are widely used in pavement construction, but their fracture performance under different environmental conditions is not fully understood. By studying how these materials perform under stress, engineers can make better decisions about material selection, leading to pavements that are more durable, cost efficient, and sustainable. Moving on to literature review summary. The literature shows that HRA has a dense aggregate matrix and higher binder content, giving it excellent deformation resistance for heavy loads but making it brittle in cold climates. HMA is more flexible and adaptable, performing better under dynamic traffic loads and in areas with temperature changes. Modifiers like fibers, polymers, and nanomaterials improve both materials performance, and modern testing methods like SCB and ideal CT offer better ways to predict cracking. Moving on to the methodology. The methodology is based on four main steps. First, we use secondary data sources, including journals and technical reports. Second, we carried out fracture testing on HRA and HMA mixtures using SCB and DCT tests to measure toughness and crack resistance. Third, we evaluate mechanical properties such as tensile strength, fatigue resistance, and elasticity. Finally, we tested environmental conditions like temperature changes and moisture to check material durability. All results were analyzed to compare the fracture resistance and overall durability of HRA versus HMA. Moving on to the research outcomes and discussion. This is a secondary research study, meaning I did not conduct lab experiments but instead analyzed and synthesized data from several peer-reviewed studies, majorly in literature review and results remaining in intro, methods, and conclusions. I reviewed studies on material composition, environmental effects, testing methods, modeling approaches, and field performance. I used fracture mechanics principles to compare properties like crack resistance, flexibility, and durability. In these reviews, I got some key results. The HRA is best for static, heavy load areas like airports or freight roads. The HMA is better for urban and mixed traffic roads due to its flexibility. Environmental conditions heavily influence fracture performance, especially moisture and freeze-thaw cycles. Adding recycled asphalt and warm mix technologies can improve sustainability without reducing durability. Neither HRA nor HMA is better. Overall performance depends on climate, traffic, and material design. The given graph shows the comparison of fracture performance of HRA versus HMA materials. Yellow color bars shows the fracture performance of HRA materials and blue color bars shows the fracture performance of HMA materials. You can see on the very left side of the graph, in static heavy load area conditions, the HRA materials shows better performance than HMA materials. In urban and mixed traffic road conditions, the HMA materials perform better than the HRA materials. In influence of environmental conditions, the HMA are better than the HRA materials. According to graph, when we use modified technologies, e.g. recycled asphalt, the HRA mixtures performance slightly good as compared to the HMA mixtures. And if I talk about flexibility under dynamic loads, then HMA materials are better than the HRA materials. Moving on to the ethical considerations. In terms of ethical considerations, this study ensures data integrity and accuracy by only using peer-reviewed and reliable sources, avoiding any misrepresentation of results. All sources, including journals, reports, and technical papers, were properly cited to respect the original authors and maintain academic integrity. Finally, since only secondary data was used, there was no direct involvement of human participants. Any confidential information was treated with respect and all sources were fully disclosed. Moving on to the conclusion. This research highlights that pavement design should be context specific instead of choosing one material over the other. Engineers should match the mix design to the environment and traffic conditions. Both materials can achieve long-term performance when enhanced with modern modifiers and designed using fracture mechanics principle. Here are some recommendations. Use fibers, hydrated lime, and polymer modifiers to improve aging and cracking resistance. Apply fracture-based testing standards like Ideal CT and SCB IFIT for better quality control. Increase use of recycled asphalt and warm mix technologies to reduce environmental impact, incorporate life cycle assessments in pavement design to ensure economic and environmental balance. Future studies should focus on long-term field monitoring to validate lab results and improve predictive models. In the given picture, you can see that how mechanical loads, temperatures, and different conditions can affect the fracture performance of these materials. Acknowledgements. I would like to express my sincere gratitude to my supervisor, Dr. Safir Ghaffari, for his constant support, guidance, and valuable insights throughout this dissertation process. His expertise was crucial in shaping the direction of my research. Thank you.